Greetings everyone. Today we will in second chapter Basic Mathematics. This will be the lecture 5th of this series. Second chapter Basic Mathematics. Lecture number 5th. So in this lecture, students, we will discuss differentiation. Right? What is differentiation? Actually, differentiation is a part of calculus, and we will discuss the theory only here of differentiation. So this would be the topic we will discuss today. Starting with function. Before moving to differentiation, I need to discuss with you all function. Why such that it happens to be x square. Okay, example. Y such that, so I could actually write y is equal to function of x. So we can say, f represents a function x is what is it? X is independent variable. Very nice, independent variable. So I'm writing independent variable, and y is dependent variable. Okay. Now suppose another example I am taking into account. Suppose y is such that it happens to be sin x. Okay, students. Y is sin x. Now you would say, sir, x is a function here, sine is also a function here. What is the function then? No, students, x is variable. Notice x is variable here and sine is the function. Okay. Then f is sine and x and y are independent variable respectively. Okay, students. Yes, sir, definitely. Now, erasing this part. Erasing this part. Now moving to differentiation. The function ends here, students. Now move to differentiation. Differentiation part. Differentiation. The slight change. What is differentiation? The slight change the slight change in the slight change or difference, or I can say, or difference in value of what, students? Of y with respect to x. Respect to x is called differentiation. This is the simplest form. This is actually the definition of differentiation. Okay, students, it's called differentiation. Yes. Example, y x square minus 4 x plus 2. So, this variable x is represented into the function such that it becomes for every value of x, y takes some value. So it is a function, but in simple terms, it is a variable represented on x-axis. Yes. For if we set now we are discussing this function, students, x square minus 4 x plus 2. Or if we set x is equal to minus 2, then what will happen, students? The function will become undefined. The function of x will become undefined. Will become undefined. Will become undefined. Will become okay. Will be undefined. Will be undefined. Okay. Will be undefined. So where it is defined? Where it is defined? The next question. Suppose x is equal to minus 2.1. We get, now I am setting x is equal to what? Minus 2.1. Okay. Then what will happen to the function? Y happens to be minus 2.1 whole square. Minus 4. This is what, students? Yes, this is minus 2.1. This is plus 2. So what I am doing, students, I am slightly changing the value of x, and I am putting it here and here. So we will see what the value of y will become. So you do the calculation for now while I am erasing. It is the beauty of mathematics that it actually uh, becomes clear with numbers. 4.1 actually the square of it, and this is what? Minus 2.1 plus 2. This is actually what? So this is 0.41, and this is minus 0.1, and this is minus 4.1. Right, students? Yes, definitely, students. This is, so you slightly change the value of minus 2.1 minus 2, and this answer is becoming very different. At x is equal to minus 1.9, we get at x is equal to minus 1.9, we get what, students? So let y happens to be minus 1.9 square minus 4 x plus 2. Oh, yes. minus 1.9. Right, students? Now you would be saying, sir, why we are doing this? Why we are doing this? Minus 2.1 and minus 1.9. Actually, I'm trying to show you that with little difference, little change in the values, how y variable is also changing. Sometimes it changes a lot, sometimes it changes not so much. But little bit change is always there because it is dy by dx. So little bit change is always occurring. With the original value, of course. Of course. So this value takes what, students? You calculated it. So this my value comes minus 3.9. Okay. Note. So what we notice, there is slight difference in values of x minus 2 and y is also changing. Y is also changing. Right, students? So at x is equal to minus 2.1, it was what, students? Y was minus 4.1. Yes, sir, definitely it was. At x happens to minus 1.9, y was minus 3.9. Okay, and x happens to minus 2, y being undefined. Like it is not giving anything reasonable. So what is this system? What did I did? So you put limit to the values. Yes, very nice. This is called limit. So what I did, x tends to minus 2 to minus 2, or mathematically that is what you write in in division also, mathematically x plus 2. Right, students? The term. So this implies slight difference or slight change in y in x. I would write. First, I will write x causes slight change in what, students? Yes, y. Very nice, students. This is the thing. So, what the next part of this? How would you represent this differentiation? Derivative of a function. How would you derive derivative of a function? Derivative of a function. Derivative of a function. Suppose y is such that f happens to be function of x. It could be anything. Then y plus del y, what it is? Y plus del y, sir. We are not getting anything. Let me show you. Then y plus del y is actually function of x plus del x. Okay, so rather saying y plus del y, I should have said function x plus del x. This should I have said. Causes y plus del y, certain change into the value of del y. Uh, I'm taking this as first equation, yes, and this as my second equation. Okay, subtracting first from second, we get what? So we don't know. So y plus del y. So you write the thing, na students? Y plus del y, and this is what? Function x plus del x and minus function of x. Right? This is the simplest thing. So this gives what? Simple subtraction del y as what? Function x plus del x, and this is what again, students? This is function of x. Now I'm taking this as third value. So what should I do? Completely up to you, sir. Dividing third, dividing third by del x. We get, now the question arises, why sir you divided by del x? Because the students, I'm comparing now. That is why. How much del y is changing with respect to del x. That is why I divided. So what happens now? Del y del x. Oh, sorry, again writing del y. Del x gives what? Function x plus del x minus function x, and this is what? Del x. Right. So this gives us this value. Also, limit del x is such that it approaches 0. Like very small. It is del means very small. So it is approaching 0. Then what should I write? This thing, and then I should write again this thing, limit del x approaches 0. This happens to be what? Function x plus del x, right? This is minus function of x, and this is what? Del x. Yes, the thing is. So the equation of dy, which is this is what dy by dx is. This is what dy by dx is. I would write limit del x plus to be 0, and this is function x plus del x, and this is minus the function x, and this is del x. Yes. So this is the thing. Physical meaning of differentiation. That how it occurs into the physics differentiation. It is mathematics partner students. So we will see how it is occurring into the nature. Some studies student would say, sir, it is velocity is dx by dt, ds by dt, anything like that. Yes, basically what you are saying is right, but we will see what lies here. Physical meaning of differentiation. Physical meaning of differentiation. Meaning of differentiation. The rate, the rate, not a word, one word should come here. What it could be? The instantaneous rate. Yes. The instantaneous rate of change, rate of change, the instantaneous rate of change. Rate is missing. Rate of change of a physical quantity, with respect to what, students? With respect to other quantity, right? With respect to other quantity is what differentiation is in physics. Physical quantity which is which is in a continuous fashion, in a continuous fashion, a continuous fashion, right, students? Which is in a continuous fashion. Okay, so it is not like that it is happening for some time now and it will not happen for other seconds. So it is in continuous fashion, and one example is gravity, acceleration due to gravity. So the next part of it, instantaneous velocity. There is missing words. Instantaneous velocity. Instantaneous velocity. So we are into the physics realm now. From mathematics to physics. V instant dx upon dt, and this is, I can also write ds upon dt. S is what? Is displacement. Very nice. At instant t. At instant, I should rub it. Instant t, not here. At instant t, instantaneous acceleration. Instantaneous acceleration. What it is, students? Sir, it is dv upon dt. Yes. But can you move one step forward? So we are moving many steps forward. So what I mean here is this. Acceleration is dv. So can I write this thing as a instant as dv upon d, and this happens to be what, students? dv instant upon dt. Right, students? Okay. So you're getting my thing. What I did, oh, sorry. Yes, it should be ds. Yes, this should do, right? So what I did, I took this value into account, v instant, and put it here. V instant is what? ds upon dt. I put it here, and dt is here. Oh yes, what dt should come also here also, I believe. No? Yes, it should come here. Yes, what you are saying is perfectly right. Otherwise, t square would not come. Yes. Instant happens to be, yes, d square s dt square, and this is what is student at instant t. At instant t, at instant t. So I would actually say that acceleration is a double differentiation of displacement, and you get instantaneous acceleration. Okay. So I will stop here for now. Thank you.